So today, very short, very straightforward lesson, and the knowledge you have from VMware Workstation will be applicable here. So let's get started so that we can get into this topic. So today we're looking at creating and managing virtual machines. We already have done that, haven't we? We've already created virtual machines and we've used it as part of testing our infrastructure that we've been building. So it's nothing new, but there's a couple of things I need to talk about, specifically the files, how we perceive the virtual hardware, and what we expect to see in the virtual hardware. So obviously today, the objective is to create a virtual machine, install the guest operating system, install the VMware tools. I think we've all done that already so far this semester or term. And then we're going to look at manage the virtual machine and then modifying the virtual machine. So nothing extraordinary. But let's actually examine the virtual machine from the inside. When I say from the inside, I'm talking about from the perspective of the operating system. What does the operating system see? Because the operating system may not know it's a virtual machine. The operating system is installed onto hardware, but in our case, in this case, it's virtualized hardware, isn't it? But what does it actually see? So sometimes these days, especially modern operating systems, know they've been virtualized. Okay, we've spoken about that in the Cert 4 with the servers, Microsoft servers, where they have the generation identifiers to actually, and it understands it's a virtual machine. But other operating systems may not, especially the older ones, may not know it's been virtualized. So you can see that if an operating system gets installed onto a piece of hardware, just like the computers in front of you, they will detect and install the drivers for the hardware. Okay, and from here you can see this is device manager, and this is inside of guest operating system. So from the guest operating system perspective, from the inside the virtual machine, it sees hardware. But you notice that some of them are VMware virtual disks, VMware SVGA, display adapters, VMware printing devices, and also the Microsoft other devices as well. But you notice that there's network card. That's interesting, isn't it? It's not seeing some sort of VMware network adapter or something like that. It's seeing a Intel Pro 1000 MT network connection. Okay, so we all know that Intel is a very big company, and basically every operating system would probably have built-in drivers for it. So it's, even if you've got a Realtek network card, so for example, what's on my computer here? Let's discover what's on my computer here. So let's go display manager. This is my physical computer, by the way. And we can see the same things. In the network adapter, you can see there's it's Intel Ethernet for this particular computer. In the other room, it comes up as a Realtek. But it doesn't matter which network adapter you have as your physical machine, it would detect it as this. Okay, so VMware ESXi presents the following generic hardware. So you know how the issue with physical computers, you install the specific drivers for the specific hardware, right? Okay, so if I've got a NVIDIA video card on these computers, I must install the NVIDIA video card. If I've got a Realtek network card, I'll install the Realtek video card, and if I've got this and I've got that, I install the specific drivers. That obviously means that we get the maximum performance. We got the maximum configurability on those pieces of hardware. Because if we don't install the specific drivers, we may not be able to configure our graphics to a higher resolution that we expect from the hardware. And that's fine, because that's actually the hardware. But if you think about it, if I have a hard drive that's installed onto these computers, and it's installed the drivers for the specific video card, the specific network card, the specific every piece of hardware that for this computer, could I take that hard drive, take it out physically, take it out of the box? I go to a computer at home, your house, I put it into your computer at home. Could I boot up from that hard drive? No. Why is that? Why is that, Robin? Well, you know why. You just don't want to explain it. Too early. It's too early in the day to explain. I'll tell you. It's basically because there's different hardware, isn't it? So the drivers that's already installed inside the operating system, you take it out and you put it on a computer at home. It's totally different hardware. You'll get heaps of problems, and you will, even if it boots, it might have problems with this and problem with that. You might have to update the drivers. You might think this is not working properly. And that's fine because they're physical machines. That's not what you're meant to do, right? But I'll ask you another question. If I took the hard drive from this computer that's behind, oops, I don't even have the good computers. You guys have the better computers. If I took the computer out of the box that's in front of you, I took the hard drive out, and I walked over to this other box in the same room here, could I put the hard drive in here and boot it up? No problem? Should work, right? Why is that? Because they're all identical, aren't they? The hardware in this room are all pretty much identical. There might be slight version difference for some of the firmware or something like that.
IP address.
Sorry, mate?
IP address might be different because of MAC.
Oh, well, the IP address doesn't matter really. That's dynamic in this room. But pretty much all the drivers that we're talking about here will be identical. And we can move around like that. And in fact, that's what we do. We actually, in the past, we create what's called drive images. Okay, with something like Ghost. We take an image of one computer and then we deploy it on all the other computers. And that's basically exactly the same hard drive image. Okay, and that's because we can guarantee they're all the same hardware. When it's not the same hardware, that's where you had the same problems. So thus far, we've been talking about the virtual machines. And we've been talking about how we can take virtual machines and we can move them around, can't we? We can actually turn it off here and then restart it there. We can migrate it while it's running and all those kind of things. And they're all really, really good features. But the problem is, can we guarantee every one of our hosts will be identical? Physically, physical hardware? No, we can't, because we might have bought 5 hosts in 2021, and we might have bought another 5 hosts in 2023 because we need to increase the amount of capacity. So we cannot guarantee every piece of hardware will be the same, can we? So that would make it almost impossible to do all those things that I just talked about, moving around. Even just plugging in your portable hard drive from home and putting it into the computers here and turning on the virtual machine. Right? But it does work, doesn't it? It does work, doesn't it? You can have different computers at home, different computers here. Even between the labs, there's different hardware, isn't it? Different processor, different amount of RAM, different hard drive, etc., etc. But you're able to take your portable hard drive and plug it into any one of those rooms and still press turn on the virtual machine. And do you ever have any problems with drivers? Never, right? Because what the operating system is a consistent virtualized hardware. That's what's called the ACE, Assured Computer Environment. And that's why it doesn't matter what physical hardware you have. The virtual hardware is what's important. The only thing that's a little bit different is the CPU. Okay, the CPU will be seen as the physical CPU here. Okay, so for example, on these computers in this room, you've got i7s. In the other room, you've got i5s. So wherever you move rooms, you just have a different CPU on your virtual machines. And because of the different CPUs, you can't actually pause a virtual machine in one room and go to the other room and resume. Can you? You've seen that before? Have you guys seen that? Have you taken a hard drive from one room, this room, let's say, gone to the A105 because a different CPU, there's i7 here, i5 over there. You can't resume the paused virtual machine, can you? It will say that it needs to restart and you'll lose the current state. That's because the CPU is different. You can't just keep on carrying on exactly the same and treating the CPU just like an i7 when it's i5. So that's the only difference. So therefore, if you do have significantly different CPUs, all right, guys, sorry about the disruption. We're talking about the assured computing environment. So the virtual hardware is identical, except for the CPU. Like we said, when you take a virtual machine from this room to a 105, different CPU, you can't resume the pause state. So if you have ESXi host with different CPU, for example, significantly different CPU, it can't just be i5 to i7, AMD to Intel, for example. But if you have similar CPU, then you can. So obviously, tip, if you're going to spec out get the specifications for the service for your host, you should make the CPU as much identical as possible. Because when we do the live migration, the vMotion, you can't vMotion to a different host with a different CPU. It's the same as restoring the save state. So key thing is generic hardware. Generic means there's not much differentiality, okay? Which is good, which means we don't have driver issues, okay? Which means that the operating system will probably have the built-in drivers. Do you ever have to download a driver for your virtual machine? Never. But if you had a brand new computer and you installed the operating systems from scratch, there's a chance you might have to go get the drivers for this and the drivers for that, and then install the drivers for your physical computer, right? So that's why I love virtual machines so much, because there's all those not silly, but those tedious little tasks is not there. Yeah, Alexi?
Maybe stupid question.
Yeah.
If we have different providers for virtual, systems.
Yeah.
Do they have
the hardware you're talking about? The hosts?
Yeah. For example, Hyper-V and VMware, do they have identical
virtual hardware? Yeah. No. You can't go from Hyper-V to VMware virtual hardware. You have to use a converter. Okay. You have to convert a virtual machine from Hyper-V to VMware.
Yeah.
And if you want to go from that direction, if you want to go the reverse direction, there's a converter that converts that way as well.
That's possible.
It's possible, definitely possible. That's part of the migration strategy, and we'll talk about that in the later part of the term. Yeah, 100%. You can migrate from one type of virtualization to another type of virtualization by use of a converter. We've already done that sort of today. This in our sessions. Have you noticed? Remember we had that OVF. Remember the OVF file, the Open Virtualization Format. Sorry, did we when we created the? Did we do it now? Did you remember any files that's got the OVF?
Yes.
With OVA, OVF.
I tried to save it, but
yeah. So basically, we'll talk about that when we're later on. But the OVF, it's an Open Virtualization Format, so it's a bit like something that's generic across all the things. So usually, what happens if you want to take a virtual machine out of this environment and put it on another environment, but you're not sure about it, you convert it into an OVF and OVA. All right, so that might be coming up later anyway, but let's see. No, not this session, but it's definitely in the future session, so we'll talk more about that later, okay? So key thing about this slide is that from the inside looking out, the hardware, it's virtualized, it's generic, and when we switch hosts, it doesn't matter because the virtual hardware is exactly the same, okay? And the genericness means that I don't have to look for drivers. It's already going to be built in, and the operating system will install it automatically, and I just basically install the operating system and use it. That's what we've been doing, haven't we? Okay, but let's keep on going. A VM can include the following types and numbers of virtual hardware devices. Those processors, you can have between 1 and 256 processors with the vSphere Virtual SMP. The number of processors depends on the virtual vSphere license you've got. So obviously, the more processors you can give to a virtual machine, the more work you can do. Okay, so if we have a system with lots of processor cores, so I'm not talking about individual CPUs now, I'm talking about cores. That's a huge number, 256. But if you think about it, even our i7, let's have a look at this CPU. Let's go to Resource Manager. If we look at our CPU, you can see there's already all these cores, 8 cores, okay? 8 cores. So there's the CPU 0 all the way to CPU 7. That means it's 8 cores, okay? let's say we have a service system. Obviously, we all know we can have dual CPU, quad CPUs, multiple physical CPUs in each of the server grade hardware. And then if each of them has 8 cores, then you can have a large number of CPU cores that you can allocate to the virtual machines. So basically, this is what it's saying. You can allocate between 1 and 256. But just a tip, if I have 8 cores on my physical machine, I do not want to allocate 8 cores to a virtual machine. Can anyone think of why? Okay, I'll give you an analogy. If I have a restaurant, or if you have a restaurant, son, all right, and I'm a customer, and your restaurant has lots of tables, okay, but it's a very busy day, and I walk into your restaurant and say, I'm looking for a table with 10. Is it easy for you to find a table with 10, or is it easier if Alexi comes in and says, I want a table for 2? Which one it will be easier for you to find, a table for 10 or a table for 2? Yeah, it's a lot easier when it's busy to find 2 free seats than 10 free seats altogether, isn't it? All at the same time. So if you think about the CPUs, if I give a virtual machine 1 CPU core, 1 CPU is equal to 1 core, I can, if the virtual machine needs to do processing, it needs to just ask the host, I need 1 core free. So then it's going to look for its cores. Oh, here's 1 free. You can have a turn processing your information. But if I allocate 8 cores to a virtual machine, and I only got physically 8 cores, then when the virtual machine wants to process something, it will ask the host, I need 8 cores. Then the host is going to look around. I don't have 8 cores now. I don't have 8 cores now. I don't have 8 cores now. I have 8 cores. You can see how it has to wait a significant longer to actually get a chance to process all 8 cores at the same time. So therefore, that's why it makes your virtual machine actually less efficient if you actually allocate too many cores based on the host. Okay, so don't allocate. If you got 8 cores, don't allocate 8 cores to your virtual machine. Okay, something like 4. It's probably a good balance between the amount of power it can process and the ability to find 4 free. Okay, it's a lot easier than 8. The memory, the maximum is 6 terabytes of RAM. So these are maximums. Okay, so obviously it's future proofing. So terabytes of RAM, that would be nice. SCSI adapters, you can have a maximum of 4 SCSI adapters with 15 devices per adapter, which gives you 60 SCSI devices per virtual machine. So SCSI, if you've never heard of it, it's a small computer system interface. It's more for connecting drives, hard drives, DVD drives. But really, if it's a virtual machine, you probably don't need 60 drives. Okay, I doubt any device, any virtual machine will actually need 60 virtual hard disks or drives. Network adapters, maximum 10. That's somewhat interesting. So 10 means you can connect it to potentially 10 different physical networks, don't you? So we're not talking about load balancing now across this network adapters, because don't forget, we still got load balancing at the physical ESXi level. We definitely can use allow us to connect to 10 different networks, definitely. Parallel ports, free parallel ports, no one really cares about that, I guess. Serial ports, maximum 4 serial ports, again, no one really cares about that. Really, no one uses a virtual machine for the serial ports or parallel ports, okay? If you don't know what they are, the serial ports is where you connect your console cable to, and the parallel ports is, in old days, is where you connect the printer to. So it's a virtual machine. Really, do we need to? We can definitely map the physical parallel port to the virtual parallel port, but there's not many applications for it, okay? Because especially with these days with the USB, we can redirect USB from host to thing as well. CD, DVD, maximum of 4. Again, really, it's only for the ISOs, mounting the ISOs. We don't really use optical media anymore. Floppy disks, don't even need to mention it really, but the old days, obviously, floppy disk, maximum 2. And a single USB controller with up to 20 USB devices, that's plenty, okay? There's plenty USB devices. The most important thing is probably the amount of amount of memory, amount of CPU. The rest of them is not such a limitation. Okay. So we've been looking at the virtual machines from the inside out, from the perspective of the operating system. Okay. What does the operating system see in a virtual machine? But if we examine it from the outside in, it's what we see as administrators on the ESXi servers or the vSphere. From the perspective of the ESXi host, a virtual machine is just a whole bunch of files. We all know that. We can go to our drive, we can see all the different files, and we choose the VMX file and we load it up in VMware Workstation, and then we turn it on, don't we? VMware Workstation then takes all the files using the VMX files as configuration and uses it and writes to it, reads from it, does all that kind of stuff. But at the end of the day, they're just a whole bunch of files. The two most common files, so it's not going to be any different for VMware Workstation and VMware vSphere. The two main ones are the VMX file and the VMDK file. VMX is a plain text file. I think we've all seen this before. Let's just see if we've got an example, just so we can see it on as example here. So let's see if there is a virtual machine here. Maybe not. No virtual machines here, but let's go to the L drive. We won't copy one down, but we'll just open up a virtual machine. I might just get this server 2019 core. That's a small one. We might copy it just in case we need it later. Okay, and that's not going to take too long, but we might just go back and just explore the virtual machine anyway. So if we, hopefully I don't change it, that's the only thing I'm scared of, because I might be editing it. So let's get the 2016 core. So here we can see the VMX file. So it's the same purpose. It's a configuration file. It's a text-based configuration file, which means if I open it with a text editor, it is in plain text. You can see what hardware version it is. It's VMware 12 hardware version. Compatibility, should I say? So let me see what version of our. So our VMware on this computer, VMware Workstation that is, it's actually 16. So if I create a new virtual machine, I'll just do typical. Or maybe I should go custom actually. That gives me more custom. See, this is the hardware compatibility issue. Hardware compatibility. So VMware 16, that's the one we've got here, is compatible with Fusion 12 and other VMware 16. So that means only these ones can open it. But if you look at this, this is the limitations: 128 gigs of RAM, 32 processors, 10 network cards, etc., etc. But if I choose 12, you can see only these ones can open it. So you can see that there's older ones can open it. So it's that if you create it with a newer hardware compatibility issue, only the newest VMware versions can open it. Whereas if you create it older, then more can. So if I was a lecturer and I wanted more people to be able to open the virtual machines, I might want to choose an older hardware compatibility. You can see we've even got the ESXi. We can create ESXi compatible virtual machines in VMware. All right, let's stick with the 12, but you can see that the limitations are 64 gigs of RAM and 16 processors. If we compare that with 16, you can see it's a significantly different, isn't it? So the hardware compatibility is basically the hardware version, and this is 12. If I keep on reading, you can see there's an ISO. This virtual machine has actually got an ISO mounted to the SATA drive 0:1. So this relates, I think I've finished copying it now. So that's the 2016 core. Let's actually close this. Let's go to our C drive and open up the 2019 core. Okay, so let's open this up with a thing, and this was actually 16. Okay, but if we keep on going down, is there a, here it is, there's an ISO. Just remember that, that's the server 2019 eval ISO. Okay, so if we actually open this up with VMware Workstation, you can see there it is. That same thing is configured here. So even though we've got this nice graphical interface for VMware Workstation when we make various configurations, you see how there's a bridge adapter. Let's have a look. Bridge network adapter. Actually, we'll just work with this one. Okay, we'll just go. We'll change this. Okay, we'll just change it to test ISO, and we'll actually cancel this. We'll remove this because we can't change it in two places. This is similar to any file. Okay, so we'll change it to test ISO. Just remember that. I'll save it, and I'll go back to my thing, and we'll open it. And if we go here, you can see this cool test ISO right here. Now, so hopefully that illustrates the fact that anything you configure with the graphical comes back to this configuration file. Anything, you can in fact change this configuration file. If you're smart enough, you know what all these things mean, you can actually come into here and make changes. If you remember, that's exactly what we did when we created the ESXi host. We actually made some certain changes to allow us to have that nested virtualization. So getting back to our slides, yeah.
So that means we can run just scripts to like configure hundreds, thousands of identical.
Yeah, definitely can. You don't have to create virtual machines from scratch like the configurator thing. You can just create the files you need and edit the files through scripts or through manual editing.
What kind of language normally?
Well, you can use, this is a text base, okay? You can use any language to generate that. Okay, so it's up to you because you're just outputting a text file, aren't you? So if you want to use you can use like even batch files to echo to a file. You can use PowerShell. You can use Python. You can pretty much any language usually has a way of generating a text file, right?
Yeah.
So as long as you understand what you're doing, you can do it with anything programmatically. And that's a good point, though. That leads us to the fact that we can automate a lot of these things. We're learning the manual way, of course, because we're learning the basics. But in the future, where you have all the basics, all the infrastructure set up, you can create automated deployment. And we'll touch upon that later when we do the templates and stuff. Okay, so there's one thing to create the virtual hardware. There's another thing to have the operating system inside the virtual hardware, isn't it? Okay, so basically when we're configuring this VMX file that I just showed you, that's to do with the virtual hardware, not the operating system that's sitting on the virtual hard disk. You get me, Alexi? All right. So that's easy. That's a text file. You can create that anyway. But how do I get the binaries inside the virtual hard disk? That's the harder part, isn't it? But when we talk about templates in the future, then there's a way. Obviously, there's a quick way, which is cloning and deploying from clones, which is cloning the template. But we'll talk about that later. All right. So VMX file is a plain text configuration file. It defines the virtual machine hardware that resides on the virtual machine, the number of CPUs, the RAM, the adapters, the MAC address. Yeah, that's interesting, isn't it? The MAC address. The networks to which the network adapters are connected, and the number and names and the location of all the virtual hard disks. Okay, let's see if we can find some of these things. So like I said, this may be a VMware Workstation one, but effectively it's the same. So I can see that that's a E100E, 1000E. That's the network adapter. So that's an Intel E1000E. If we look at the, look, if we keep on looking at some of these things, all right, Ethernet generated address. So that's the MAC address. Okay, and if we look at the yeah, the thing is, it's all text, so sometimes it's very easy to make a mistake when you're typing it, and it's very hard to pick out things. The memory size, I can see that's 2 gigs of RAM, and the number of CPUs, that's pretty much easy. Let's have a quick look up here. Power type, PCI bridge. I'm picking out stuff that's easy to. All right. Comparability hosted. So this is actually a hosted virtualization, which is as opposed to the bare metal virtualization, which is what ESXi is. All right, CD-ROM image. I'm looking for true. Ethernet 0 present true. Okay, let's see if we can find. All right, generated. So find next. It's a E1000E. It's true. It's that one. That's the MAC address. That's that one, and that's about it. All right, so we can pick out those things. Okay, so I've got to admit, it's only the things you need to use you learn. Okay, so this is telling me that's a NVMe virtual hard disk. It's not because it's an NVMe. That's the type of hardware it's presenting to the virtual machine operating system, and this is the virtual hard disk that we're using. And then if we go back here, you can see that there is the virtual hard disk here. All right, so the VMX file pulls everything together. The other file that's important is the VMDK file, and we should have experience with this. They're virtual hard disk files. Okay, so anything with is a virtual hard disk file. Let's see if we can find this. We got so we've got this one and we've got this one. Okay, so this is obviously the original. What do you think this one is? You can see this one's big, this one's small. What do you think? Why do you think we got 2 virtual hard disks when we really only have 1 virtual hard disk? Can anyone think as why? Is anyone keeping an eye on Razor? Maybe he's got all the answers. Maybe he's got all the answers, but I'm not listening to him. So can anyone try to guess why we've got 2 virtual hard disk files when we've only got 1 virtual hard disk? And you notice that this name of the 2 is very similar, isn't it? It's only some numbers at the back.
Maybe some changes in the small one.
Yeah, it's definitely changes. You're on the right track. So, Son, you got something to add to it? I think you were about to say something. Sorry?
I thought we see the backup one.
Backup one? There's no backup here. If you lose, I can tell you now, if you lose this one or you lose that one, the virtual machine won't work properly. Okay? I'm suspecting this virtual machine has a snapshot. Let's check. So VM, snapshot manager. Oh, look, it does, doesn't it? As a snapshot. What happens during a snapshot? What happens? What is the point of a snapshot? What do you get? Come on, guys, you know this.
You're going to roll back.
Yeah, it's a point in time capture of the virtual machine, isn't it? So therefore, if I've got a point in time capture, do I want the hard drive to change anymore? Do I want the hard drive to change if I've got a backup? What's the snapshot of it? No. So what happens then? What happens when you take a snapshot is, let's take another one. Look at that, we've got another virtual hard disk file, haven't I? So basically, you got to understand that this is the original hard disk. It's got all the stuff in there. We took a snapshot, so we froze it. Just like what Alexis said, then this is the changes that happened after the snapshot. But then we took another snapshot, so we froze that one. Then this is the changes since that snapshot. You get me, guys? So each one of these ones are generated as after the snapshot is created, freezes the previous hard drive. And that's why we got it. All right, so let's wait on 1 second, Alexi. Your timing has to wait a little bit because I was just in the mid flow. If I go to snapshots and I go to snapshot manager and I go and delete that now. All gone. And let's even delete this because I don't really care about this particular virtual machine. No more VMDK files except for the original one, right? Because we don't have the snapshots anymore. So when we take a snapshot, we freeze the virtual hard disk exactly as it is because we want to preserve the data. Then we create a new one for any new changes to it. Alexi, what's your question?
So if we have two snapshots, and for example, we delete the first one,
yeah,
the second one won't work?
No. So if you do it properly, all right. So if we take a snapshot, and we'll take a snapshot, and then we take another snapshot, and we take another snapshot. Okay. So let's say that we are here, but we want to delete this one, right? That's what you say. So let's firstly look at this. Okay. So we've got all these things. So when we go, if we do it properly, not just manually delete it, okay? If we do it properly, if we delete this, what it does is just collates. See that little processing part? What happens is it combines the changes into the next one.
Okay.
So that's what it does. It just combines the changes. Okay. If you do it properly, if you do it incorrectly, let's take a snapshot. And we'll close this and we'll go here. So we've got the two. And if we go here and we just delete the file, that's a different story, isn't it? We didn't have a chance of collating the differences. Okay, so now I know we're doing this rather than the thing, but it's all related anyway. If we go to, let's see if we can power on. See, it's got missing files now because we did it incorrectly. I'm looking for 2, but there's no 2. There's only 3.
So the entire virtual machine won't stop?
Not necessarily. There's little tricks you can do. There's always some tricks you can do. Because I know there's no difference. Okay? Because I know there was no difference between the 2 snapshots. You get me? I do little tricks like that. Okay, even the other day, like Natalia, you might know her from another class. She somehow broke her golden master and broke all these virtual machines, and her hard drives were there, but she couldn't turn it on because it was missing this file, missing that file. So what I did was I created a new virtual machine, but put her hard drives in there and replaced the new hard drives with the old hard drives, and then was able to boot up. The theory is it's like me taking the hard drive out of this computer and put it into a different computer, exactly the same hardware specs. So there's always little tricks, but not always guaranteed to work, depending on how much difference there is between the snapshots, okay? So you can see I did what I did there and it's still gonna work, okay? All right, so let's go back to our slides. I think we're getting divergence into different things, different aspects. It's good that you have questions, definitely, and it's obviously related because we're now understanding a little bit more about the virtual hard disk and snapshots and why it's this and there. So it's all related. So I don't mind. I just want to make sure I still cover all the data that I need to cover. Okay. So each VMDK file represents a hard drive. Additional VMDK files can be added by providing additional storage locations, and each VMDK would appear as a physical hard drive inside the virtual machine. So if we look at this, it's the same. Same when you browse a virtual machine, whether it's ESXi or it's a VMware workstation, the format's pretty much the same. It's got a VMDK file here, 9 gigs. It's got a swap file. Okay, so don't worry about that. It's just focus on the VMDK. If you don't know what a swap file is, it's basically temporary storage for memory. Okay, but that's it, 9 gigs. Okay, but it's being provisioned for 41 gigs or 42 gigs. And if we actually go to the command line, the PuTTY, and connect to the console, we can see all the files there as well. There are 2 different files that compose a virtual hard disk. Okay, this is a thing. Both of them use the VMDK extension, but each performs a slightly different role. One is a VMDK header file, so it's almost like a descriptor, and the other is a flat file, which is the binary file, which contains the binary. But when you go to the browser, you only see a single file. Okay, but if we look at this one, all right, you see that you've got this file here, VMDK, something -2 VMDK here. See that? All right, and then you got the same one that's here. So it says flat. You notice that that's the big file, and this one is a very tiny file. That is the header file, and that's the binary file. Do you understand when I said binary file? Binary files contains the data, okay? Whereas the header file is descriptor for the virtual hard disk. So that's something that's a little bit tricky that we're probably not aware of, but that's why we're talking about it. But when we go to the browser, we only see the VMDK file, and that's how we work with it most of the times. We don't need to necessarily need to work with the flat file. Separately, that means, okay? The VMDK header file is a plain text file, contains the configuration information pointer to the flat file. It's almost a bit like the idea of the file allocation table for a hard drive, okay? Typically, it's very small. The VMDK flat file is a binary file. It contains the actual data for the virtual hard disk. It could be as large as the size of the virtual hard disk. When the VM is running, there will most likely be a virtual swap file, VSWP file, which is a VM kernel swap file. So, have you heard of the term swap before? Sorry? Swap. And where have you heard this before? Come on, guys. You guys have all studied here.
Operation system.
Which operating system?
Windows.
Windows doesn't call it a swap. Windows call it a paging file. Linux, correct. Linux calls a swap, doesn't it? You even create a swap partition, doesn't it? What's a swap? You've heard of it, but what is it? Okay, this is Linux 101. Installing Linux, you create a Linux swap partition. What's it for?
CentOS.
Oh, CentOS uses it, yes. So does Red Hat, so does every other Linux distribution, including ESXi. If you don't realize it, it's a Linux underlying operating system. But what is the point of the swap? Okay, you guys may be more familiar with Windows then. What's the point of the page file in Windows? So in Windows is called paging or page file, and in Linux is called swap. What are they? So in Linux, we even create a whole partition for it called a swap partition. What is it? All right, so instead of, we'll shortcut this.
Reza has an answer.
Oh, Reza has an answer. Good. Okay, let's have a look. It's like a buffering. It needs more. Nah. Yeah, you're sort of on the right track. It's what's called the virtual memory. Heard of that term before? Virtual memory. It's basically you turn a part of the hard drive into virtual RAM. So if you can't fit a lot of things, as much things into the RAM, which is small usually but fast, you put it into the swap. So it's temporary, like Reza is trying to say, buffering, but it's the virtual memory. So basically, that's why it's when the virtual machine is running. The RAM there's nothing in RAM when the virtual machine is off, isn't it? So this is the virtual memory is running. So if I look at the previous previous one, I can see there was a swap, wasn't it? That's about 4 gigs. 4 gigs, that's probably, I'm guessing that's probably got, this whole virtual machine's probably got 4 gigs of RAM as well. I don't know for sure, but I'm guessing. But you can see that that's a virtual swap file. Okay, so that's the virtual machines swap, or virtual memory if you like. Okay, so there will also be NVRAM file, which is the file settings. So of course you guys all heard of NVRAM. What does NV stand for? Come on. You guys have done Cisco, have you? Non-volatile. Yeah, so things that don't change. RAM is always changing, isn't it? The firmware doesn't change. NVRAM is where the BIOS settings sit. And again, is because we don't have a real BIOS, we have NVRAM. So I'm guessing this machine, this virtual machine here that I've got here, it was not shut down properly, and that's why we got these lock files, and we've got this NVRAM, and let's have a look at what else we got. And yeah, that's all we got. And we've got these snapshot stuff, which is what we just did before. All right, so yeah, hopefully we're learning a bit today. So let's continue. So here's the VMDK header file. Like I said, it's a bit like a descriptor. It's a plain text file, but all of this doesn't really make any sense to most of us. But obviously, again, the hardware version and stuff like that. But as long as you understand that the header file and the flat file works together, it refers to the flat file. And I can tell that's probably gonna be about 8 gigs-ish. Running VMs from previous versions of ESXi. So unlike upgrades from previous major versions, ESXi version 6 allows, version 5 allows you to run VMs created in earlier versions of ESXi without any sort of upgrades. VMware tools and upgrading the virtual machine from 4 or version 7 to version 8 can be scheduled and performed at a later date. So that's just basically upgrading the VMware tools. Do you know where your memory is? The settings on this page is not guaranteed that the physical memory will be achieved in the configuration value. So what is it talking about? It's hard to understand, isn't it? So let's actually look at a virtual machine. So this virtual machine again, it says it's got 2 gigs. Okay, it's saying it's got 2 gigs of RAM. Is that 2 gigs of RAM? Or is that 2 gigs of something? That's what that line is talking about. So on my physical machine, if I turn on this virtual machine, it will try to give it 2 gigs of physical RAM that's in here, in the box, okay? But what if there's not enough RAM? What if there's so many virtual machines running at the same time? What if all the physical RAM is used up? What would it do? What? Page file, this temporary virtual memory, right? That we talked about just before. Okay, so it will create a virtual memory. So therefore, if you think about it, some of this 2 gigs may not be in physical RAM. Some of it might be virtual RAM in the swap files or in the page files. Okay, Robin's understanding, he's good. So therefore, that is what this is talking about. We'll talk more about that when we talk about the resource allocation. But memory for the VM might be physical RAM or the swap file, or a combination of the two. You're not guaranteed. Okay, unless in the future we'll talk about the reservations and we talk about resource allocation, then we can sort of guarantee it that way. But let me just show you something while we're here talking about that anyway. Sorry, go here. Go to VMware. Let's go to our VMware edit preferences. So if we go to our memory, you see, so this is a VMware workstation. So obviously we can draw from this and extrapolate to the other vSphere as well. We've got 32 gigs of RAM on this physical computer. It will limit the amount of RAM given to virtual machines to 28 28 gigs. Okay, we can adjust this, but obviously it becomes dangerous if we go too high because the operating system on the physical machine might die. Basically, we can adjust it below that, or we can adjust it to that limit. But if we go over the limit, we'll start having problems. Okay, so the amount of reserve RAM is greater than the recommended maximum and might degrade the system performance, which means your system will die, run really slowly. So best not to do that. But if we look at this additional memory, so how should the system allocate memory for virtual machines? Fit all virtual machines into reserve memory? That means if we can't fit it in there, we don't start it. Or allow some virtual memory to be swapped. That's what we're talking about just then, isn't it? So therefore, even if we reach this maximum 28 gigs of RAM, then some of that memory that the virtual machine needs will be on the hard drive. Okay, that's why when we run short on memory, everything runs so slowly, doesn't it? And here, if we choose this one, allow most virtual machine memory to be swapped, that would just even make it even more slow. Well, if we know anything about hardware, we should know that RAM is fast, super fast. Hard drives are really slow. SSD is slightly better, but nothing replaces the speed of the RAM. RAM is, that's why you can get like a 2 terabyte solid state hard drive is not too expensive, but if you try to get 2 terabytes of RAM, that's very, very expensive. All right, keep on going. All right, so that's what that last line is. What about adding existing disks? So that's what I said. If you've got an existing virtual machine, it has some VMDK files. Let's just do that as an experiment. Okay, so let's do that as an experiment on VMware Workstation because it basically works the same. So let's just go to a new virtual machine, and we'll close this other window. We'll go custom. It's a VMware, whatever. I'll install later. It's a Microsoft server because that's what we're dealing with. I forgot which version. It doesn't really matter, I guess, because it really doesn't. We'll call this test. All right, and what about the virtual? We'll keep those the same. Memory is the same. The network doesn't matter. The hard drive doesn't matter. We will, instead of create a new virtual hard drive, we'll use an existing hard drive. Oh, where's the hard drive? Let's go and find that. Yeah, so that's on the C drive. Let's find that VMDK file there. So if you remember, that was part of the other virtual machine, wasn't it? So we're using an existing virtual hard disk. We could create a new. We'll even keep the existing format, and we'll finish. So this is our test virtual machine now, isn't it? But I'm using the virtual hard disk that's part of this virtual machine. Let's see if we can power it on. Yeah, that's okay. Oops. Maybe I need to get this, remove this. Let's reset it. Oh, you know why? All right, let me just do it again in a different way. Power off. Let's go to here. The VMDK. Here it is. I might just do a little bit different in my demonstration. Bear with me. That's this one. That's this one. And what we'll do is we will get rid of all the snapshots. Oops. Delete. 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 All right, and we will remove this. Okay. And there's the VMDK file now. I might just make a copy of it and put it outside of that virtual machine so it's not being used in any way by that virtual machine. And then in my server one, I would edit this virtual machine, and with the hard drive, we will remove this hard drive and we will add a new hard disk. Was it NVMe? Yeah, I think that was using existing disk, and we will browse it. So, you know why? It's the VMware version. Sorry guys, let me just cancel that whole process, delete this. All right, let's create a new virtual machine, and we will customize and we'll make it older. Let's make it 12. And we will just call it that test again. Test 2 then, okay. And we might choose the BIOS. I think that's what I chose for that particular virtual machine. So everything else has to be the same. Yeah. Let's see if we can use that existing disk. So everything has to be the same. That's the only issue I think I'm having. Is incompatible. Let's try one last time. Let's firstly look at this VMX file. I know. So let's have a look at this. This is a NVMe and options. All right, so let's open this. All right, so first of all, it's a hardware 16. Okay, it's NVMe, and the BIOS. This is taking a little bit longer. All right, let's do it like this. We'll do 16 there, and we'll make it so it's VMware. Use the BIOS, I believe. That doesn't matter. LS Logic, NVMe, use existing hard drive, and let's browse for this one. Let's just try that, and we will cannot connect to it because the corresponding is not available to the host. No. Yeah, there we go. So if you look at that, I took a long time because I'm not familiar with this particular virtual machine. But when we found out a few things, you can see that I've taken a existing virtual machine hard drive and put it into a new virtual machine. Okay, so we can do that definitely. All right, sorry for taking so long. So the existing virtual hard disk doesn't have to contain an instance of the operating system, but we could still, it could be just whole data. It could just contain data. We could just take the data drive from one virtual machine and connect it to another virtual machine. It can contain data that perhaps will serve as a secondary drive in a virtual machine. The ability to add existing disk with data makes the virtual hard disk extremely portable, generally allowing users to move them from one VM to another VM without too much problems. You will obviously need to address the guest OS specific issues like partition, file system type, and permissions. So what is that saying? Obviously, I was moving a virtual machine hard disk from a Windows computer to make another Windows computer, because Windows can recognize NTFS, can't they? So if I take a data partition, which is a Linux format, okay, and try to put it into a virtual machine, which is a Windows server, you'll probably realize that's going to have problems with, isn't it? It's a bit like you taking your portable hard disk that's been formatted EXTFS or something like that, and plugging it into your Windows 10 computer. You won't be able to read the partition. Drive provisioning. So that provisioning means making the drives. To create virtual disks, with all the space allocated, but not pre-zeroed. It's called fixed provisioning, lazy zeroed. Okay, in this case, the flat file or the virtual VMDK file will be the same size as the virtual disk. So what does that mean? If I create a 60 gig virtual hard disk, the file will be 60 gigs straight away, even if there's zero data on it. That's what fixed provisioning is. That's like our version of allocating disk space straight away. If you want to create a virtual disk with all the space allocated, but all the bits zeroed, that's called fixed provisioning, eager zeroed. So why do we want a lazy zero or eager zero? What does it matter? This option is required in order to support the vSphere fault tolerance. Remember the lockstep? If everything has to be the same here and here, if they're not all zeroed, then it's not predictable, isn't it? Which bit is zeroed, which one's not zeroed. You get me? It's wherever's there. So therefore, if we eager zero, we zero all of the bits. That means we can guarantee they're exactly the same state. This option means full-size VMDK file is the same size as the virtual hard disk. To create a virtual disk with space allocated on demand, so that means if you create a 60 gig virtual hard disk, you might end up with a 2 gig VMDK file. It's called thin provision. That's where you don't allocate all the space straight away. So what's the advantage of this? The advantage is obviously you don't use up all the space straight away, right? Just like what we're doing in our class. But what's the advantage of actually creating the fixed provisioning? It's actually better performance if you allocate the space straight away. In this case, the VMDK file, so with the thin provisioning, the VMDK file will grow depending on the amount of data you actually store on it, up to the maximum size you've defined. Naming the virtual machine. So this is something I do. This is something you should do if you follow my recommendation, is that you name the virtual machine exactly the same as what you're going to name the operating system computer name. So if the virtual machine is ADL RWDC, because that's what you're going to make it, the ADL read-write domain controller, then the virtual machine folder files should be called that as well. Okay, that's just my opinion, and I think that's what it's saying here as well, because it just means that if I'm looking for the ADL RWDC virtual machine on the network, it'll correspond with the files that I'm looking at. You should also avoid spaces and special characters. That's not allowed in a standard DNS naming preference. If spaces are used, the virtual display name then using the command line to manage the VMs becomes tricky, and DNS host names cannot include spaces. Display names of VMs should match the host names configured in the guests being installed. The display name assigned to the VM should become the name of the folder. That's what I was saying just before. And at the file level, we know that if we give it a name, then every file, the VMX file, the VMDK file, follows that naming convention, doesn't it? What about VMs and physical machines? Provisioning virtual machines is not the same as provisioning a physical machine. In the physical world, you provision a server based on the maximum you think. So what does that mean? So if I think my server's on October the 31st is going to be this much capacity. So, do you know what October 31st is all about? That's Halloween, right? But sorry, I'm getting my thing wrong. You know the Black Friday sales? Yeah, that's not Halloween actually. That's after a certain holiday, right? Black Friday. Like we all know that day, if you got online sales and your server is going to be crazy, right? If we buy a physical server, we think of the busiest time. We go buy the hardware for that, right? And that's fine, because we can't change the physical server after we buy it. We can certainly upgrade it, but it's very hard to change, okay? So in the physical world, you provision servers based on the maximus, the biggest sale in its lifetime. In the virtual environment, you should just provision the files of what you actually really need 99% of the time. Because just because on Black Friday sales you have 1,000% increase in traffic, wherever. But what about all the other days? All the other 364 days, do they need all that? Okay, so you actually with virtual machine you create the resources as they're needed. Additional resources can be added later. That's the flexibility of virtual machines. You can just quickly increase it, quickly reconfigure it. Well then, so this is a funny one. So this is a slide that I wouldn't even worry about normally, but it's just because it's funny. So under the Apple Mac, so you can Mac OS, you heard of that? On the Mac that's installed on Apple Macs, they have a special they have a special license clause. So in Microsoft Windows or Linux, do they have anything to do with what hardware you can install on? Do they say Microsoft Windows 10, let's say, can only be installed on Microsoft hardware? Do they say that anywhere? No. Most things don't. But the funny thing is, Apple operating system, Mac OS, can only be installed on Mac hardware. That's part of the license agreement. So you definitely can virtualize Mac OS, but you'll see that most people don't. The reason is, if I actually virtualize a Mac OS and put on this piece of hardware that's in front of me, I'll be breaking the law, breaking the copyright. Just between us, there's plenty of how-tos on the internet of how to visualize Mac OS, because maybe you need to just do some testing, or maybe you need to just learn how to program in Mac OS so you can develop iOS programs, but you don't have a Mac OS. There's plenty of instructions on how to do it. So it's possible. So 1 second, timing, okay? Apple Mac OS server, X server, is a physical hardware that's a server based. This allows you to run Mac OS servers, VMs, on your VMware ESXi if you install ESXi onto a Mac OS hardware. So critically, it's important to note that this is only supported when ESXi is on a specific model of Apple Xserve servers. Okay, Alexi?
If I remember correctly, Apple moved from their old processors to x86 processors.
Yeah.
And then year or two ago.
Yeah, PowerPC.
Yes,
yeah,
well,
that's right.
That's why it was possible to install.
Absolutely. So while they were using x86 processors, that's why you could see all these MacBooks with dual boot Windows. Have you seen that? Yeah, the boot camp. Heard of that? No. All right. So that's okay. So side note. Okay. So because when they had the Intel processors, the people used to use boot camp to dual boot Mac OS and Windows OS because they can have the best of both worlds. So, but you're right, Alexi. They've got the PowerPC processors now, which is a little bit more efficient, but it works differently. So this may not be specifically true, but when this was written, it was true. But the licensing still is true. Okay, working with installation media. So we all know that with that, so we can use the client device. What does that mean? I can just put a CD-ROM or a USB stick into my client computer and have that redirected through the network to the virtual machine, so that it'd be as if you plugged it into the virtual machine itself, or the host itself. We can also use the host device, which means on the ESXi server, I put a CD-ROM in or a USB stick in, and that redirects to your virtual machine. So if we have a look at that, that's just a bit like when we edit this virtual machine. And when we look at this DVD, for example, we can use the physical device, or we can use a ISO. So this physical device is like the host physical device, isn't it? All right. So, and if we look at USB controller, I think if we had the redirect, if it was on, we could have the removable devices, and then we could actually, if we plug in USB here, we can connect, we can look at the settings, and we can connect to a physical device if we wanted to. All right. But ISO is what most people use, okay? And that's what we've been using pretty much everywhere. So the last option is to map an ISO into a VM. So ISO, if you don't know, is just an image of a optical drive. Even though we don't even use optical drive media now, we still have ISOs. Okay, that's the funny thing. But from ISOs, we can then build optical discs, or we can actually use it to burn physical optical discs like CDs or DVDs. But we can also use use the ISO to create bootable USBs as well. So ISO format is widely supported by many different software vendors. So it doesn't matter which software, which operating system you use, ISO is an ISO. Okay. Oh, sorry, wrong way. What about the virtual machine console? So that's the screen you use to interact with the virtual machines. From the VM console, you can do anything you need to do on the virtual machine. You can access the virtual machine's BIOS by modifying the settings. We can turn on the power to power on. Sorry, turn the power on to the VM off or on. So we can actually turn it off and on. We can interact with the guest operating system. We can add the concept of focus. So I'm sure you're all familiar with it. If you click into the console, you are interacting with the guest or the virtual machine. If you take the mouse out of the console, especially if you got VMware tools on, that means you're doing it on the host computer. So we all know that. So, but until you have VMware tools installed, you have to press the Control-Alt to release it from the virtual machine. So that's the same as VMware Workstation, isn't it? But obviously, one of our first things we do with any virtual machine installation is to install VMware tools. Okay, that should be your default standard operating procedure. When you press Control-Alt keystroke combination, the vSphere client causes the VM to currently has control of the mouse and keyboard to release it. So installing VMware tools. So we all know the things about VMware tools. Allows you to copy and paste, allows you to have to shift focus from the guest to the host or the client in this case, without using the keystrokes. So VMware tools is not installed by default, but it offers so many benefits that you should be part of your normal tasks. So it has basically parallel virtualized devices do not have device drivers presented as standard installation of the guest operating system. So if you haven't heard the term para, it means half basically. So some devices are only half virtualized. So a bit like the CPU. Okay, the CPU is dependent on what physical CPU you have. It's presented as a physical CPU, as the same version of the physical CPU to the guest, but depending on how many cores you select, it will show the guest how many cores. Installing VMware tools should be a standard practice. VMware tools provides the following. It optimizes SCSI drivers, it enhances video mouse drivers. There's the heartbeat, remember? We talked about the heartbeat, VM heartbeat. There's a VM quiescence for snapshots and backups. Quiescence, if you've never heard that term, it means make them happy. Okay? So basically, if I want to take a snapshot of a virtual machine, I have to tell it to sort of stop what it's doing momentarily, take a snapshot. So obviously, that's not the normal thing an operating system or computer does, right? So the quiescence means keep them happy for a bit so that it doesn't complain about being sort of the snapshot process. So that's what it means. It's the way it does it it's not important for us as long as we understand that without VMware tools, it's taking the snapshots is harder and backup, especially running systems and backing them up completely because they're constantly changing the files, aren't they? Enhanced memory management as well. VMware tools also helps streamline and automate the management of the VM focus. Remember the Control-Alt, release focus, and so forth. So here's the VMware tools. Older operating systems, Windows operating system, can improve the responsiveness. So we can adjust the responsiveness of the hardware acceleration. It is by default set to none. Setting to maximum makes it more smoother. And this is highly recommended for optimize the graphical performance of the VM console. Windows XP has a value set to maximum. So when we're talking about older operating system, we're talking about the era of Windows XP. That's quite old, isn't it? So most modern operating systems, you don't necessarily need to do that. Managing virtual machines. how do we add an existing, so you know how we got virtual machines. We copy it and we put it into the data store. It's not going to be in our list of virtual machines. We have to go find the VMXO files. We're going to right click and we have to add to inventory. That's what's called registry. We can also create virtual machines from scratch. We've done that before. When you create a virtual machine, the VMX and VMDK files you want to open in your environment, you can also upload folders containing a virtual machine to a data store, and then you register it. Power states, I'm not going to go through all of these. We all know what these are. We can power on, power off, pause, reset. That's like physically to a physical machine, pressing the power button, holding it down until it goes down. Restart, shut down and restart the guest, basically shuts it down properly. Restart obviously shuts it down properly and then restarts it up. Removing and deleting virtual machines, we can certainly take it out of inventory as well. So we don't have to delete it. We can right click and just remove from inventory. Just like we just added to add to inventory just before. But in the event that your virtual machine is no longer needed, we can delete it completely. Okay, be careful. If you're going to delete it completely, like anything, if you delete something, it's gone. Okay, if you don't have a backup, it's gone. Okay, so it can't be undone. To delete the VM completely or entirely, you only need to right click and power off the VM, the power off VM, and select delete from disk. It's a bit like, it's the same idea as this, guys. It's the same idea as this. We've got the inventory here. We can right click, remove. Does that remove the virtual machine? This will delete the virtual machine from, this will not delete the virtual machine's virtual disks. So it's just removing it from inventory. But we can also right click and manage and delete from disk, which actually just completely deletes it. Better not do that. I will do that actually. No, I will do it because it was mine specifically. All right, we're nearly there. And modifying virtual machine. So changing virtual machine virtual hardware. In most cases, modifying virtual machine requires that the virtual machine be powered off. So just think about it this way. On a physical machine, what can you change of the physical machine without turning it off? So these are just normal machines, right? Not talking about server grade machines or anything like that. Can I upgrade the RAM with it running?
Yes.
No, with this machine.
No.
No, can I put more RAM into it while this is running?
No.
Can I take RAM out of it while it's running? Can I put a new hard drive in this while it's running? Or remove a hard drive? No. All right. So this is just a regular machine. So if you can't do it to a physical machine, you probably can't do it to a virtual machine as well. Obviously, if you have special hardware, server grade hardware, and special operating system which supports hot swappable stuff, then yes, you can do it. So changing virtual machines usually requires them to be turned off. The exception to this rule is, so I didn't finish my other one, but remember how I said, can you do this, can you do that? You said you can't, but let me ask you a few more. Can you unplug your USB stick while it's turned on? Yes. You can plug a new one in, can you? Can you change the network cable while it's on?
Yes.
Yes, we can change the network cable from one to another while it's on, can't we? We can do all of those kind of things. We can plug in all of those things. So if you can do that, you can do it on a virtual machine as well. So you can hot add USB controllers, Ethernet adapters, hard disks, or even SCSI devices. The Server 2008 or the server grade virtual machines also supports addition of virtual CPUs or RAM while they're powered on, because those are the operating system can support it. But VMware disables this feature, and basically to enable this feature, you have to turn it off anyway, which is probably a one-time thing. Virtual machine snapshots. So we all understand what snapshots are. We've spoken about snapshots today quite a bit as well. They're point-in-time capture of the virtual machine state. So wherever the machine's on the, and wherever is on the virtual machine at that point in time, wherever the virtual machine is doing at that time, it can be off, it can be on, it will be captured. And once it's captured, if the administrator can revert it to that point in time by going to that snapshot. And it just go back to exactly like that. There's two options for snapshots. The snapshot, we can snapshot the virtual machine's memory specific, where the RAM of the virtual machine should also be included in the snapshot. When this option is selected, the current contents of the virtual machine RAM are written to the VMSN file extension. So that's while the virtual machine is running. So quiesce guest file systems. So again, quiesce means keep them happy. So we need VMware tools to take a snapshot of the virtual machine while it's running. The quiescence basically means control whether the guest file system will be quieted, or the guest operating system is considered consistent. This can ensure that the data within the guest file system is intact for the snapshot. So that's the same word again, quiesce. It quietens them down. Okay. Yeah, don't worry about it. It's an English word. Not everyone can. Yeah, that's why sometimes I always ask, do you know this English word? Because for someone with English as a first language, no problems. But for all of us in this room and online, including Reza, it's not our first language, is it?
It's like the first time I came across the word acquainted.
Acquainted. Yeah. All right, so if we look at this snapshots, so I think I showed you this before. This is the original drive. Okay, then we take a snapshot, then that is frozen, then we create a new hard drive. We make changes, 2 gigs of changes by the looks of it. We took another snapshot, and that's frozen as well, and that is created. So if we go back in a snapshot, then we just basically go back to that point in time, that hard drive. All right. So with the snapshot manager, looks something similar to this. It's very familiar for us if we work with VMware Workstation. You can see just by the relationship from one snapshot to another, it's linear. You've probably seen other snapshots where there's a fork and there's a tree. You can go several directions because you can go here, go there. That's fine for our classroom environment because maybe we've got this snapshot for this purpose and we'll go here to go there. Then we've got this other snapshot for this other purpose and we'll go here and we'll go down that track. But for a production virtual machine, which are your servers, usually that's not the case. Usually it's just linear. All right, so that's the end of today's PowerPoint, and we'll get you to keep on working on your worksheets.